Hello students, so continuing our lectures in mathematical physics, we will start with statistical distribution. Now in statistical distribution, the first topic that we will take up is binomial distribution. Now in binomial distribution, the probability of obtaining x success in n independent trials, so there are n independent trials and we are getting x success values where p is the probability of success and q is the probability of failure in a single trial. So these two are meant for a single trial. Then the binomial distribution function can be written as bx that is equal to n factorial divided by x factorial into n minus x factorial into p to the power x into q to the power n minus x. And this is nothing but this part is nothing but the combination function, that is cx into px, p to the power x and q to the power n minus x. And now the bx is normalized. So we can write summation x is equal to 0 to n bx is equal to 1. Then it is a discrete value. And the mean value is given as n into p. And the standard deviation sigma is equal to root n p into q. So this is binomial distribution. The next distribution is Poisson distribution. Now, according to Poisson distribution, the probability that x successful event or x events will occur per unit time when the mean rate of occurrence is m is the mean rate of occurrence and then it is given by this probability distribution is given by Poisson distribution. It is Vx is equal to e to the power minus m into n to the power x divided by x factorial, where x is taking our values 0, 1, 2, 3. Again, this Poisson distribution is normalized. So that will make it x is equal to 0 to infinity, Vx equal to 1, and it is also a discrete function. Now, when this np is held fixed and n into p, this is fixed, then Vx tends to Px when n tends to infinity. That means whenever distribution tends to Poisson's distribution as n is increased to infinity. Now again, in case of Poisson distribution, expectation value is equal to m, and the standard deviation sigma is equal to root m, and the properties associated with the Poisson distribution are Pm minus 1 is equal to Pm, and Px minus 1 is equal to x by m into Pm, and Px plus 1 is equal to m divided by m plus 1 into Px. So this is all about Poisson distribution. Next we have something called a normal, or it's also called Gaussian distribution. So in this distribution, if P is held fixed, the probability of occurrence and event is held fixed, and the variable distribution Bx will then lead to this normal distribution, as n is tends to infinity. And so it is, it has the form fx dx is equal to 1 by root 2 pi sigma and e to the power minus x minus m whole square divided by 2 sigma square dx. This is the normal distribution, where m is the mean and sigma is the standard deviation. So here the probability of occurrence of a single random event, so probability of occurrence of a single random event in the interval m minus sigma and m plus sigma. This is 0.6826, and between minus m minus 2 sigma and m plus 2 sigma, the probability of occurrence is 0.973. So if you look into the interval distribution, then if the data contains n time intervals, the number of time intervals n between t1 and t2, time t1 and t2 is given as n is equal to capital N e to the power minus a t1 minus e to the power minus a t2. Where a is the average number of intervals per unit time. So short intervals are more favored than long intervals. And there are two limiting cases to it. The first one is when t2 is equal to infinity. So we can have n as equal to n 0 to the power minus lambda t. This is the law of radioactivity. So this gives the number of surviving atoms per unit time, gives the decay rate or the number of surviving atoms per unit time after the radioactive decay has taken place. And the second limiting case, so there are two limiting cases, is when the starting point, that means t1 is equal to 0, then you can have n is equal to n0 into 1 minus e to the power minus lambda t. This is for radioactive decays. This gives a number of decays at interval 0 and t. So for radioactive decay, it gives number of decays in the time interval 0 and t.